Today I discuss one important topics related to normed linear space. Okay, we start from Cauchy sequence and obviously shows about that some convergent and absolutely convergent series in this way. Okay, in complete space every absolutely convergent series in convergent series we show these topics. Okay, so we start now from definition. Okay, we start from definition. First we write about that let xn be a sequence, xn be a sequence in xd, in some space matrix space xd. Okay, then what happened, then xn be Cauchy sequence if Cauchy sequence if this one, yeah, n equal to 1 to infinity d of xn plus 1 xn less than plus infinity. Okay, so this one in norm space, then how we handle this one, so easily we write this one. Okay, yeah, let xn be a sequence in xd, then xn be Cauchy sequence, sorry, xd not, here we write wrong, x norm. Okay, some norm space, then xn be Cauchy if norm of summation n equal to 1 to infinity norm of xn plus 1 difference xn less than plus infinity. Okay, so we do it in norm space how Cauchy sequence is behave, and definition of Cauchy sequence in matrix space and norm space. Okay, so next we're going to be one proposition related to this Cauchy sequence. We'll erase that portion now and going to discuss about one proposition. Okay, let xn be a Cauchy sequence in a norm space, in a norm space if there is a subsequence xni, if there is a subsequence xni of xn such that xni converges to x belongs to this x. Okay, then what happened, then obviously xn converges to x. That means what we write here, obviously some subsequence convergent in a, and this xn be Cauchy, then this xn convergent. Okay, so xn convergent when if xn Cauchy and some subsequence of xn convergent. Okay, so we write it in this way so easily: xn Cauchy and some subsequence of xn of, we write it in note, okay, of xn convergent, then xn convergent. Okay, to easily we write this note. Okay, so we're going to proof of that proposition. Okay, proof of that proposition we're going to discuss now. We write here, let epsilon greater than 0 be given. Okay, and since xn be Cauchy, since xn be Cauchy, then there exists n0 belongs to natural number such that here xm difference xn less than epsilon by 2 for all m n greater than equal to n0. Okay, and suppose that there is a subsequence, suppose that there is a subsequence xni of xn such that xni, okay, converge to x belongs to x, then what happened? Then there exists ni0 belongs to natural number, okay, such that norm of xni difference x less than epsilon by 2, okay, for all ni greater than ni0. So now we erase our portion and going to further discussion of that. We write here n equal to maximum of n0 ni0, okay, then for n greater than equal to this natural number, mod of xn difference x equal to here mod of x difference xni plus xni difference xn, okay. So this less than equal to xni difference xn plus xni difference x, okay. This less than epsilon by 2 here equal to epsilon, okay, and obviously this one for all n greater than equal to n, okay. Then what happened, what we get, we erase lower portion and we get that this one xn, then xn converts to x, okay. So our proof is too easily done. So what we learned from here, we learned one important topics from here. Also discuss definition of Cauchy sequence, and obviously one Cauchy sequence in a norm space when his subsequence is convergent, one subsequence, then obviously this Cauchy sequence is convergent. Okay, one important result of norm space. So we erase that portion and going to further discussion of another theorem. Okay, so we write it now. We write this theorem. We write this theorem here and write in this way. Let X norm be a norm space. Then the following are equivalent. Then the following are equivalent. Okay, first one, X be complete. Second one, every absolutely convergent sequence convergent series in X is convergent in X. Okay, when X is complete, then every absolutely convergent sequence is convergent. We also proved A implies B in previous class, but we also do this now because here we whole proof we do it. Okay, so first we prove what? First we prove A implies B. Okay, first we prove it. How we prove this one? We write here, let n equal to k to infinity norm of xk be convergent. Let Tn equal to norm of xk plus 1 dot norm of xn. Okay, and Sn equal to here x1 x2 xk plus 1 dot xn. Okay, now Tn convergent, this one is given. Okay, so this implies that Tn be Cauchy. Yes or no? Convergent, that implies Cauchy. So there exists k0 belongs to z such that here this Tm is obviously one real number, so this modulus Tm difference Tn, okay, less than epsilon for all m n greater than equal to k0. Okay, this implies that here mod of this one norm xn plus 1 norm xn plus 2 plus dot norm xm less than epsilon. Okay, for all mn greater than equal to k0. Then what happened? Then we write in this way here. Here we write, so norm of xn plus 1, okay, dot 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 xn plus 2 dot 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 norm of xn xm, this less than equal to norm of xn plus 1 plus norm of xn plus 2 plus dot 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 norm of xm. Okay, modulus of this. Okay, then this less than epsilon for all mn greater than equal to k0. Okay, so we erase that portion and going to further discussion of that. Take Sn equal to xk plus 1 dot 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 xn, and here norm of xsm difference xn less than epsilon for all mn greater than equal to k0. Thus xn be Cauchy. Since xn be Cauchy, and x be complete, so Sn be convergent. Okay, Sn Cauchy and x complete, so Sn convergent. That is summation n equal to k to infinity xn be convergent. Okay, okay, so first portion is done. Now we're going to second portion, b implies a. Okay, b implies a, that means we write, suppose that every absolutely convergent series, every absolutely convergent series in X be convergent in X. Okay, thus we have to show that X be complete. Okay, for this let xn be Cauchy sequence in X. Okay, we read our portion and going to further discussion of that. Okay, so what we write here, since x and b Cauchy, since x and b Cauchy, then we show that for each k belongs to n, then what happened? This one. Okay, okay, so then what we done, thus be absolutely convergent. Okay, that means from Cauchy to we show that absolutely convergent. Okay, this series, and now we're going to make conclusion of that. I erase lower portion and going to further discussion of that. Here, hence, be convergent also. Since convergent in X, since by assumption, that means X complete. Okay, not X complete, we have to prove if this one is given, that means absolutely convergent implies conversion by assumption. Okay, given, we have to prove X complete. So what we prove, that means Cauchy sequence convergent. Okay, we take Cauchy sequence and we're going to be discussion about that convergent of Cauchy sequence. Now define here uk equal to x and k. Then what? Then k equal to 1 to infinity uk plus 1 difference uk be convergent in X. that is this one, k equal to 1 to n converges to u belongs to x. Okay, then what happened? We erase our portion. Okay, this one, so this converts to what? So what happened? Belongs to x. Okay, so what we get? We get obviously since xn be Cauchy and some subsequence xnn be subsequence of xn be convergent in x. Okay, so what happened from this proposition, previous proposition? What we get? We get that this xn be convergent in x. So what happened? So x be complete, because any convergent, any Cauchy sequence be convergent, so x be complete. Okay, so we also discuss this, that means important theorem. Complete implies every absolutely, x complete implies every absolutely convergent series is convergent, and every convergent, absolutely convergent series in x is convergent in x implies that x complete. This one obviously one important that means result of non-linear space also discussed today. And if you get this type of video, please like or comment or that means subscribe this channel. Okay, like it, and obviously any question arise then write it in comment box. So today I stop here, and if you get this type of video, please subscribe my channel. Okay, I stop here.